the cosmos from building these artefacts, because they would see these artefacts as a threat. They could become so superior to us that they may treat human beings as a pest. And to avoid that risk, the only risk the Terrans will accept is zero. In other words, the artefacts must never be built. But that's absolutely opposed to what the cosmos want, for whom it's almost kind of religion to build these godlike creatures, because they feel they would be God-building. And hence the war. And in 21st century, second half probably, with 21st century weapons, if you extrapolate up the graph of people killed in major wars, you're then predicting what I call giga death. In other words, billions of people killed in the most passionate war that humanity has ever known, because the stake this time has never been so high. It's not the survival of a country, as was 20th century wars. This time it's the survival of the species, human beings, us. So that's what I told them. And it caused a delay of an hour. There was so much discussion, which was great. I mean, I've never had that in China before. They were young, 20s, 30s. The English was good, so maybe that was the factor. They understood. I spoke slowly and clearly. So there was I don't know, 30, 40 minutes of discussion, which delayed things quite a bit. So encouraging. So I'm trying to get this message across. I was making a nationalistic claim, appealing to the Chinese ego, that this is the dominant question of the 21st century. Should humanity build artefacts? And so I was appealing to the nationalist ego that the culture, in other words China, that will dominate the 21st century, the dominant culture, should be the intellectual leader in the debate on the issue, the question, that will dominate the 21st century. So I hope it sunk home. All right. Well, back to nitty-gritty. But the really interesting this board and the next, before we finish this chapter 4, I've personally found fascinating. I don't know, this time round, perhaps it's the way Sipser presents it, but it sort of hit home much more deeply than when Papa Dimitri, or whatever his name was, the last time I went through it. It's a fascinating experience. I hope you find the same. This board and the next as we go through it. Right? Now, previous board, we showed the what Sipser calls correspondence, what the pure mathematicians call bijection. Same thing. Learn and memorize both. Correspondence, because that's the term you're going to keep hearing probably throughout the rest of the text. It's the term that Sipser uses. But I'd like you to learn also bijection, because that's the standard term, well, at least in math physics. And after all, throughout this whole several decades of deGarisMPC courses, I'm trying to get you to become pure mathematicians and physicists, or in a sense almost mathicists. Okay. So we were, previous board, showing that there was a correspondence, a bijection, between the positive rationals, okay, so m over n, m and n are the members of the natural numbers, positive integers, and big N, which are the natural numbers, countable numbers, positive integers, 1, 2, 3, ... Okay? So now they're both infinite sets, and revising here a bit, if you can pair them off, one-to-one and onto, in other words, a bijection or correspondence, as Sipser says, then by definition they have the same size. That was George Cantor. That was his innovation in the late 1800s. So you may think that it's possible to do that for any two infinite sets by doing something similar with the way that the bijection was set up between these two infinite sets of Q, the positive rationals, and N, the set of natural numbers, positive integers. Okay, well, it doesn't work that way. The answer is no. There are sets that are even bigger, and you may balk a bit at the idea of using the word larger in the context of infinite sets, right? In fact, the set of real numbers, which are represented by this symbol here, it's a capital R, but here it is again. So you draw a capital R, and to the left you draw a second vertical bar. So it looks like this. This is a standard symbol in math for real numbers, usually. Well, you'll come across other symbols, maybe just a capital R, or it might be in italics or something. But this is pretty standard in the pure mathematics texts. Right? Well, it turns out that capital R cannot be brought into a bijection with big N, with the natural numbers. It's in a sense bigger than that, and that's what Cantor proved using his diagonalization technique, and we will actually do that this board. So we're getting closer and closer to the big moment. I'll have to wait till next board, I'm afraid. Well, we start on in the fourth session. The halting problem is unsolvable. So we're getting close, but the big punchline will be for next board, and then I can give my trumpet roll. Okay, right? So you might think that you take any two infinite sets, and you might be able to form a bijection or correspondence, Sipser terminology, between those two. The answer is no. And a counterexample is against that idea is the set of reals. That the set of reals is in a certain sense bigger than the set of natural numbers, big N. Okay, and sets like that are bigger than the set of natural numbers, for which you cannot form a bijection. Such sets, because they're too big, such sets are called uncountable. Okay, they're not countable, which is sort of a fairly obvious term. Right? So big R is uncountable. Right. So what we're leading towards now is a theorem which states, well, here it is here, just simply that big R, in other words, the set of real numbers, is uncountable. And theorem 4.17, chapter 4, the 17th thing we've come across in this chapter so far. All right? Perhaps a little revision on what a real number is for those of you who are more computer science and don't have a strong math background. What is a real number? Think of it as just a decimal number, where you can have an infinite number of decimal digits to the right of the decimal point. Okay. Sipser